apps in the cloud. Real quick, in order of appearance. So I'm Nick Garkusha, and Corey Fowler is my partner here, both from Microsoft. And today we have a special guest star appearing, Eli White from Musketeers. Yeah. The fact that we're working for Microsoft, don't hold it against us. We wake up and go to work like any one of you, just wearing different gear. So we're here to talk about a project that we just built and released. Eli almost tripped. Yeah. So we built a framework that we used actually yesterday. Many of you may have seen on Twitter, essentially to manage a social contest application. This is an extension to an earlier project that I'll go into a little bit of history about, but this is something that's live and running. You can see the URL in the bottom there. And this really is an interesting way to showcase some of the development patterns and practices for cloud-based applications that Corey is going to break down. Eli will share his experience working with the PHP tools and frameworks that were used to build this application. And I'll talk a little bit about the history of the project just to set the context, how it got started and what it really does. Like a lot of good things, this project came from Canada, where Corey and I, a couple years ago, started on Make Web Not War event, which was actually part of Kung Fu. Anybody here has been to Kung Fu? Kung Fu Montreal, pretty big open source event in Canada. And essentially what we've been doing at events like this is hang out with the community, talk about different technologies, have different sessions. And we found that a lot of times we would use things like they were just being displayed, which is the Twitter screen, and or depending on the setup, sometimes you have word clouds that pop up based on the content that's being streamed from different social media. The one challenge is that we found is that we would always struggle with picking a tool to show. So we had visible tweets, we had just a straightforward Twitter feeds, and sometimes we'd switch over to Facebook, and sometimes we'd have Instagram photos. And we really wanted to come up with something that had everything in one place. We wanted to have feeds from different social media, and we wanted to have photos, we wanted to have a way to visualize all of this in one place. Now, in the past, I've been doing this for about 15 years. In the past, when I would go to my IT guys and say, hey, listen, I need a project for my event that's coming up, and I want it fast, but also I need it to scale because I don't know if I need 1 server or 10 servers or 20 servers depending on the load of social media, and also want to be managing it myself. In the past, my guys would look at me and say, are you crazy? You know, this is like the end of the world. Don't even go there. We're not going to be able to do this for you. And what happened is that quite recently, we're able to build projects just like this super easily, turning the end of the world to kind of unicorns and rainbows. Why? Is because cloud changed a lot of these discussions. In fact, with cloud, we were able to get these projects started and create it really fast, be able to also scale our cloud resources. So, hey, we wanted 1 VM or 10 VMs, it's not a problem. We wanted to auto-scale, not a problem. And also, I myself was able to manage this and deploy these projects on an as-needed basis and manage them during events and during kind of proceeding to events on my own. So we ended up coming up and building what we call SocialCloud. It's an open source project. We sponsored a couple of different partners to develop this. This is a screenshot at Kung Fu and in our area, and we had it kind of live and running. And this essentially scrapes social media and displays it, and Corey's going to go a little bit into architecture of this. I'm just going to highlight a couple of main points. First, we had from an end-user experience, a front end, which is always really good, and kind of taking best practices of API first. We wanted to make sure that we created services that expose an API, and this front end really just consumes the APIs. HTML5 Canvas app uses Create.js, and essentially just would consume the JSON from the Socket.io feed. Then notice this is a Node.js. The original project was Node.js project that Eli extended with PHP, but also kind of shows well how different pieces can work well together depending on what they do best. And this was an HTML5 project running on Azure websites. So this is the front end. The actual server that served up the the JSON socket.io service. This is an example of what was being ran. Well, actually, we have this running live, and we had this running yesterday. And all it does is takes and exposes a socket.io using Node.js and Express.js, does a little bit of filtering, but also listens on an Azure Service Bus, and Corey's going to go into more detail what that really is. But we use the messaging-based architecture to decouple different pieces of the app. We thought it was a decent practice for scalable apps. And surprise, it runs on Windows Azure and a Linux VM, Ubuntu Linux VM. Which kind of shows a couple different things. One is you can run multiple different frameworks, including open source frameworks, directly on Windows Azure Platform as a Service, but also you can run VMs, just as we did with this specific thing. And then we decided, hey, it would be good to have a backend to manage this. So this is also a Node.js project and uses Express. And a lot of the content that comes through, we cache and store in MongoDB. And again, we use Service Bus to do the message management, message queuing. And again, from an API first perspective, we wanted to expose not just the streaming API, but also an API to the admin piece so that we could administer the entire project anywhere from a mobile device or from a web API. So without further ado, kind of why are we here is because we took that project that was built about a year ago or so and extended it to do some cool things with PHP that Corey and Eli will talk about. And fundamentally, to have a front end, which is on the top, and to have a back end, which is on the bottom here, a way to manage entries, and essentially just kind of to frame anybody starting today at 11 o'clock could come in and take a photo of your experience as ZenCon, tweet with ZenCon Windows Azure, and then that kind of takes the tweets, SocialCloud scrapes it, puts it into Service Bus. We see these tweets come out in the back end as incoming entries, whether approved or denied. Once the entry is approved randomly or on a 30-minute basis or hourly basis, we can pick a winner. And then that gets presented on the very top. So kind of to go into more detail, I'll let Corey go through and talk about the architecture.
Great, thanks, Nick. So before I get started, there's some interesting numbers in the keynote, and I want to get a gauge for the room to see if people are here to figure out what the cloud is or if you're already using it. So could you put your hand up if you're already deploying something in the cloud today? Yeah, I'd say that's about 70% of the room. Awesome, great job. So a lot of people think about architecture in a traditional fashion where you have a server and a SQL server of some sort, and you're just kind of interacting between the two. Now this is interesting because you can throw a little bit more towards the server side of it, but then people always forget that you can't really scale up that SQL Server database as well. So the problem that you start running into is you have way too many pieces of information that you're trying to store really quickly, especially in something like a social application, and one of those pieces is going to fall over eventually. So when we went and so basically everyone's kind of like, okay, wow, this doesn't work anymore. So we kind of went down the line of going, okay, well, how can we make this scale? And we kind of came up with an overall architecture looking at, okay, obviously we want to pull from things like Twitter, Foursquare, Instagram, any other social media that might be out there. So we went and we created a server that was going to pull all of those tweets in from their respective APIs. We knew we needed to get lots of those. So all of these little individual server pieces are made so we can scale them out. And because we need to scale them out, and we might need to scale them out independently, that's the reason we broke them apart into different servers. So we draw everything in. We start pushing tweets across to queue. Very simple. The other web server picks it up and starts streaming it down into our HTML5 Canvas application. The MongoDB server that you see there is basically setting some configuration settings, but also keeping track of other messages that are coming down the line, just so we have a nice event store of all the things that are going on. And this is something that you could go do in any cloud platform. But obviously we went and we implemented it on Windows Azure. So we went out and we said, okay, well, the first server makes sense to be a Linux VM. It's there. We have the ability to go out and auto-scale our VM. So let's go and we'll implement our code there. And then we weren't too sure what we wanted to do with it. So we have this service bus. Has anyone done message-based architecture before? A couple people? What have you used in the past? RabbitMQ. And you, sir? Same? Okay, cool. So a topic for the people that aren't familiar with it is a way to send messages out to different pipelines. And basically every single server on the other side is going to connect to that topic, and that will be a separate subscription. And then basically what happens is those messages that you're sending across the wire are going to fan out to all those subscribers. So because we didn't know how far this was going to go, we didn't want to go and implement a queue that's just going to send messages across the wire. So we added the ability to kind of filter that out. And this worked out really well for us. So we basically moved across, decided to do the real-time stuff in Linux VM as well. It was a really great place to run Socket.io because we could just go and open up WebSocket support there. These little globes are what we call Windows Azure websites. And Windows Azure websites are really simple ways to get going. Basically what you do is you can set up a server in seconds. It's running IIS. You can just go and deploy your code. But the benefit to running a website for something like an HTML5 Canvas app instead of using a virtual machine is the cost. We can run that in a shared environment if we don't really need so many different servers, but we can still scale that out. Or we can go and we can dedicate a full virtual machine to that and let it go and scale on its own. We also decided to use a mobile service, which is another feature of Windows Azure, and basically that allowed us to go take the administration portal and push it out to a device. Because when you're at events, you never know what's going to happen. You want to make sure that you can go and approve things that are sitting in the incoming queue, so you can show the people that have entered into a contest or anything like that, like we did today, or for this event. And that was something that was simple just to hook up to the existing API. Then we decided, all right, well, let's run the social contest. So we have the existing SocialCloud, and you can see here the same components. We have our VM that's already set up. We have our topic, but now we have a new set of infrastructure that we've rolled in. And we have a virtual machine that's just going to be a new subscriber to that topic, so it's going to receive all those messages just like the other one did. But we're going to be able to change them differently. So the application that Eli wrote will pull those in, and what it does is if there's an image involved, it actually parses the URL, realizes there's an image, and goes and saves that image off to blob storage. The reason for that is when you're building these cloud scale applications, you are relying on a lot of APIs. And the crazy thing is those external APIs can go down. You have no control over them. And the whole concept of the cloud is making sure that you're resilient to other services, or even your own services have the ability to fail over in a time of need. So that was the reason we decided to pull all those images in, save them out to blob storage ourselves. So if Twitter was to go down, because that never happens, we had the ability to keep the images up and displaying through our social application. We also went out and archived the tweets and basically pushed it into 4 separate queues, which is the 4 items you see over on the right-hand side there. So all of the tweets that were coming through from that topic kind of went into an incoming queue. And once we've decided that, yes, the content is nice to push out into the public, we drop that into an approval queue. And basically that allows us to feed things back. So you can see in this diagram here, we're basically doing like a loop back into the virtual machine that we have available to us. But we only have about 800 people or so here. What if we were running this contest worldwide and we really had to be, we had to make sure that we could scale beyond what we had? So we could kind of pull that into an architecture like this, where we have our virtual machines pulling all of the tweets coming off, and that can be scaled out. And that job is kind of atomic and can go push things out to blob storage on its own, pull tweets in, push them onto the queue, and nothing's the matter. Once we go with that, we might have multiple operators that are going and actually approving items, because this is a worldwide contest. One person's job sitting there and hitting approve is going to be really hard to do with the amount of tweets that you could come in. So that allowed us to, or that would allow us to go scale this out beyond the architecture that we had today. And we should be able to handle a lot more. So all of this can be done sitting within the global footprint of Windows Azure. So we have 4 data centers sitting in the US, 2 sitting in Europe, and 2 sitting in Asia. And then all of those orange dots that you see are CDN locations. So if we wanted to be able to support worldwide, our storage account that's saving all of those images, we can push into a CDN and be able to serve all of those images up at a global scale. To get going a lot quicker, there's this VM depot. And basically what that is a whole archive of pre-made virtual machine images. So if you have your favorite LAMP stack, you can go out, find something that's running exactly what you need, and get it going in Windows Azure relatively quickly. We also have a set of command line tools, and this allows you to basically control your entire subscription straight from your right from terminal sitting on your Mac, which most of the people in the room are running. And basically, I'll just quickly jump into here and show you a little bit of what the command line looks like. All right. So all of these are implemented in Node.js. So it's something that can work on a Mac, Linux, Windows, and nothing, you won't see a difference between the 3. So I can just type in a command to Azure after installing the npm package. And what this allows us to do is kind of go through and see all of the different options that we have. So I'm going to choose websites because that's the simple one. So I'm just going to say Azure site. And at any time, you can just --help, and it gives you all the list of commands that you can do. So as you can see, one of those websites that we had, you can go in, start, stop the server, set additional configurations. You can actually manage deployments. So our websites feature has the ability to pull in from GitHub, and you can configure all that stuff in here. You can see right at the bottom of the screen there, Azure Site Deployment GitHub, and that would allow you to go and do something. Now, one of the cool things is you can actually scale directly from the command line as well. So if it's something that you want to go and play with and have a lot of your friends go out and hit it, say you're really popular on Twitter, you can get people to go, you can scale instantly there as well. But there's also some great stuff to do in the management portal. And everything that you can do in the management portal, for the most part, is represented here in the CLI. But it just really depends on how you work. So this is our Windows Azure management portal. It's full HTML, so if you have any device, I've actually sat on a bus at one point, remembered that I was running a VM that I was playing around with the night before, pulled out my phone, went to the portal, and got it all shut down straight from my phone. So it's a great, nice, simple HTML application. You can use it from anywhere. Actually, at Sunshine PHP last year, we had someone that did one of the contests that we were running down there completely from an iPad, which was pretty impressive. I was pretty impressed. So just to get something started, I'm just going to go and create a simple website. So we'll just go Azure website, quick create, and we'll just say hello PHP. Obviously, that's going to be taken. There we go. And like I said, it's the quickest way to get going within Windows Azure. So you can literally, within a couple seconds here, see that my site's already created. I can go into the dashboard, look at metrics on what's running. Obviously, there's nothing there because I just created it. But you have the ability to do a whole lot of things here. So if you configured a database in one of the custom things, you could go and say view connection string. We can go and set up deployment. So we have TFS, a local Git repository. So if you're just doing some simple dev test kind of workflow, you can say local Git repository. We can pull in from GitHub. You can even pull in from Dropbox, which is pretty exciting, just to be able to quickly go and deploy your code out there. And the last one I just want to mention is Bitbucket support as well. And we do support both public and private repositories there. So that's pretty exciting. So I'm just going to say GitHub just to get us one really simple site. So you can see it goes off and uses OAuth to actually go. I forgot this is your account. Is there something that I can pull in from your account? Thank you. There we go. So basically what it does is it goes off to GitHub, sets up a webhook. So anytime you check in, GitHub's going to call out to this Windows Azure website, say, hey, I have some new code, you might want to pull it in, and it'll go and do so. So you can actually see here we have a new active deployment. That means it's pulled everything over already, and we can just go hit browse and browse off to the front end, and hopefully it will actually display something.
Oh.
All right.
It will. It's just loading up.
I'm wasting valuable seconds here.
That's okay. You can go back to this.
All right, so that was a quick look at the command line tools in the portal. So the thing that you're interested in, building on top of a cloud platform. So basically every single cloud platform will have an API that you're going to need to call into to be able to manage resources or interact with other parts of the platform. So you can go in and download the PHP SDK. It's open source on GitHub, as you can see. We support Composer to be able to install it. There's a great README file. In fact, some of the feedback we've gotten is the README file is one of the best they've seen out there. And it was really easy just to go in and understand what needed to be done to get some services going. You could also install via pair and basically use that to your ability. And basically, you're going to go through a bit around your experience with the SDK, so I won't go too much more detail on that. And speaking of which, the developer experience. So you just want to give us a quick run-through of what it was like to build
Sure.
out an app.
So again, everyone, my name is Eli White, and the company I'm with, Musketeers Me, got contacted by Microsoft because they wanted someone to come in and build this for them, and someone who were used to doing PHP development. And in our company, we're very used to doing PHP development always on the cloud and on Ubuntu and Linux. And they wanted us to come in and work on this, and then to give them their feedback, and then to come and talk to you all about it. So, like I said, because we are used to doing Linux development and on Ubuntu, we realized that we could just simply deploy this into an Ubuntu box on Azure. So that was really easy for us. We also went and used the unpronounceable name, but P-U-P-H-P-E-T. I'm not going to attempt to pronounce it because it always comes out very bad. We were able to go there and just very easily find a vagrant configuration that modeled the Azure specs that Azure would give us for its Linux Ubuntu boxes. We were able to find one very easily, and therefore able to create a vagrant and Puppet script that would automatically generate the server for us that we could use for development and share amongst our team that we were all working on it. And then we were able to go in and configure Composer to install all of the PHP dependencies that we were going to be doing. And so what it meant was, because we knew we were going to open source this at the end, we were able to go in and generate a development environment that was exactly identical to what we are used to using anyway. The fact that it was being deployed on Windows Azure didn't matter, and we were able to create this environment that we would then be able to have. We had 3 different developers working on it at various points, as well as a designer. And the designer was just as easily able to use Vagrant Up to create a box locally, get it running, go in and do any design work that was needed. The other thing is that we were able to really use what we consider typical best practices for deployment, and we were able to do that on Azure. So, at least for us and for all the clients we end up working with, the best practice that we usually prefer to instruct our clients that they're most likely going to be using if we're working with them is that once we have any code ready, that for a release, that code gets tagged. And from that tag, we then rsync it up to the live server or multiple live servers into a new directory. So we will have a deployments directory that will end up having lots of different directories of code inside of it, one for each release that's been done. And inside of that, there'll be a symlink, perhaps called current. And that symlink points to whatever the current released version is as a directory. So now anytime we need to deploy, all that we have to do is rsync over this new code to as many servers out there as we need to get it to, and then very quickly issue a multi-SSH command to tell all the servers to change their symlink from the old directory to the new directory. And Azure supported us doing this just as easily. Now, in this case, we cheated a little bit because we were just trying to get this up and running quickly for ZenCon here. So instead of actually rsyncing to new directories and changing symlinks, we just rsynced right over top of the old directory that was there, and that worked just fine for the situation as well, because we weren't in the situation of having a live running server that we were constantly trying to make sure that we had atomic switches to the new version and atomic switches back. And that's actually one of the best parts of deploying this way and using symlinks to directories, is that rollbacks become instant. Because if you need to roll back to an older version of the code, it's just changing a symlink back to the version that you know worked. And you don't have to sit there and wait for an entire deploy process to run again, getting the old version back up there. Given that we knew we were making this to be run at first at ZenCon, we decided that we absolutely wanted to use Zim Framework 2. It just seemed the right thing to do. And Zim Framework 2 is a great framework to be using. However, in this case, this is a very straightforward app. It basically has two endpoints. There's the front end, which is what you see if you're at Microsoft's booth being displayed up there. And then there's an admin endpoint on the back end that allows, as Corey and Nick were talking, for you to be able to move things from incoming to approval and then to select a winner and to deny entries if it's something that should not have come in. And so because of that, we actually just wanted something simple, but we still wanted to build it on top of Zim Framework 2. So we actually used Flighty, which is the micro framework that's written on top of Zim Framework 2 that was created by Matthew Werafini, the lead developer of Zim Framework 2. And it worked flawlessly for us. It was great. We were able to get it in, get it up and going almost instantly, and immediately start writing code. And we still had the power of Zim Framework 2 behind us. So for the beginning of this, first of all, as Nick was talking about, we were using SocialCloud, the already open source Node.js app that was scanning Twitter and Foursquare and Instagram and all those for us. So we didn't have to worry about that. The fire hose was already being provided to us into a Azure Service Bus, Azure Service Bus queue. And then behind the scenes, that was all being stored in MongoDB for us. So all we then had to do was to be able to go and start pulling things off of that queue. And the nice thing about the SocialCloud app is it already handles doing a lot of the filtering for us. So the SocialCloud app can be configured to say it only wants to see ZenCon tweets, for example. And then we're just automatically pulling in only the ZenCon tweets. So there were a number of goals we had with this app that we needed to generate. So it was to accept these messages coming from the SocialCloud. It was then to allow additional filtering. Because, for example, in this specific case, they wanted the SocialCloud app to be running on just the ZenCon hashtag so that they could display the SocialCloud and the nice visualizations they were showing earlier about anything going on with ZenCon. But to enter the contest that was going to be created, you needed to not only use the ZenCon hashtag, but the Windows Azure hashtag. So we needed to build an additional filtering layer inside of this app as well. And again, we needed to have that ability to move entries between what's essentially 4 queues. The incoming queue, which is everything coming off of the SocialCloud, and then moving them either to accepted or approved or denied, and then also choosing approved ones to become winning entries. We also wanted to have a little fun with some nice logic in there of being able to specify that you wanted the app to run from specific dates and to start at a certain time because that's when the expo hall opens, to stop at a certain time because the expo hall ends, And even though it's running, say, you set it up to run from Monday morning to Thursday at some point, to be able to say, oh, but the contest only runs from 9 to 5 each day or from 1 to 7 each day, so that the contest automatically shuts itself down in those off hours. And we also added in the ability to have it automatically pick winners. You can pick random winners out of it, and you can actually configure it to say that every half hour or every hour, it would automatically pick a new winner and add them to the winners queue, and they would appear as a winner automatically chosen. And then to be able to go in on the admin side and to be able to select any of the winners and to have it automatically generate an editable tweet to congratulate that winner for winning and to tell them to come back to the booth and pick up their prize. And like I said, we needed to have two endpoints of this. There was the front-end display that would show all of the incoming messages as well as the winners, and then the admin interface to take care of it on the back. So for the original architecture, we kind of stuck with what we knew because we only got contacted a few weeks ago and this needed to be built quickly. And Azure let us do that to get a proof of concept up to make sure this worked. So we were able to very quickly set up, as PHP developers, the majority of PHP apps out there happen to be written on PHP and using MySQL, and that's a very common setup for us. So what we were able to very quickly do was to generate an app that took all of these messages coming off the service bus queue, and we simply moved them into an Azure SQL Server instance. And so we were able to just drop them into a table and have a flag on any row for whether it was approved, denied, or a winner as they came in. And as far as images went, the images were still being hosted back to the original source. So if the image came from TwitPic, for example, all we were doing was storing in this database table the URL off to that image. And it worked. We were able to get that thrown up quickly, and it was up and running, and it was working well. The problem was that wasn't really web scale because it was just running in a SQL Server instance. Now, SQL Server can be easily scaled. You can always get larger instances, increase the capacity of the database server. But as Nick was talking, the idea behind this app wasn't just that it was going to be used here at ZenCon, but that this could be used for any contest at any time. And someone could choose to go out and run a global contest. If Microsoft wanted to use this to suddenly announce tomorrow to the world, hey everyone, tweet an image of what you're doing right now and use this hashtag and you're entered in a global contest, we needed this contest app to be able to suddenly handle that. And trying to suddenly add a whole bunch of more SQL servers and worry about replication and other stuff just simply wasn't in the books. So what we ended up doing was refactored the code, and we were able to do this within a day, and that was how easy it was, to use Azure Tables, which is their automatically scaling NoSQL offering. And it was very simple to just take the code we'd written, and we actually abstracted it out, so the code, as it's open sourced, you actually have the ability to choose to run it with the Azure SQL Server backend or with the table service backend. And what ended up happening is we also went and used the Azure Service Bus queue as well. So what happens is that messages come in on this incoming queue, and we have various scripts running that are running all the time and checking like every configurable, but like checking once a second or once a minute for any new messages that come in. And so there are 4 of these running that are looking at 4 different queues. So as a message comes in on the incoming queue from the SocialCloud app, there's one running that just takes any of these and it throws them all up. And if you, on the admin side, go in and say, okay, of these 300 incoming that I now see, I would like to approve these 20. Those 20 messages get removed from the original incoming queue, and they are put off onto another queue, on an approval queue. And then the process that's running will see those appearing in the queue, and then we'll pull them all and write them off to an Azure table in bulk for more permanent storage, since you're not going to use a service bus queue for permanent storage. And part of the reason to do that was efficiency of being able to process these in bulk. Because, again, if this is being run on a global scale, we didn't want for every single time one admin went into the back panel and clicked, I want to approve this one, to have it being pulled out of one database table and written back to another database table on the fly, one by one by one. So instead, as you choose to do that, there's simply these messages thrown off into the message queue, and they pile up, and then you're able to pull those off as you want in bulk and to do the write off to another table. And this actually allows you to scale in a couple different ways. One way you can scale is you could actually have multiple servers all running this process that's pulling things off the queue and writing it off to the table. And so you can scale it horizontally like that. You can also scale to some amount vertically by simply doing larger bulk batches. Because it's efficient to write to Azure Table Service in bulk, you're able to simply have your script, instead of running once a second, having it running in once every 30 seconds or once a minute or once every 5 minutes, and to find a larger bulk of messages off the queue and to do one connection, one write to write everything out to the Azure Table Service. And there was one last thing we realized at that point, which Nick already talked on, is everyone knows that Twitter never goes down. Never, ever, right? And TwitPic is no exception to that. So we didn't want the fact that we had in the Azure cloud, in this table service, we had all this information about all these tweets and who happened to do the tweet. However, if we were still hosting leaving those images hosted on TwitPic, if TwitPic went down or if even the local network went down, we would have the information about who did it and the words they used and the hashtags they used, but we wouldn't actually have their image to then display in the app. So we decided that we wanted to go and refactor this part as well. And again, within a day, we were able to do this, where instead of just storing a URL off to TwitPic, we instead went out and fetched that image that had been sent and stored it locally into Azure Blob Storage. Oh, not locally, stored it into the cloud in Azure Blob Storage, but locally within the cloud. And that way, we had that information stored for ourselves. And that also means that we have it stored and archived for all time. So even if an image that had been sent at one point, because anything put out there, someone might take that image back down. Or TwitPic might delete the image after a long enough point of time. And so the idea is that now we have archived all of the tweets, who did the tweet, their user image, as well as the image that they posted, and we have that all archived so that from a contest point of view, we can keep that. We have it saved. And if, for example, when running a contest, if you had requirements that you had to keep all of that information for legal requirements based upon what country and state you are in, of the requirements of running a contest, sometimes it is put out there that you must archive all that and keep it for at least a certain period of time. And now that's all archived and you have it all. And you're able to withstand any amount of external services going down. And that's really where it is today. We did open source this. It's on github.com/musketeersme/socialcontest. We'd love it if you downloaded it, played around with it, give us feedback, pull requests happily accepted. We've been working on it. We also, Corey was wearing a very apt t-shirt yesterday. He was wearing the t-shirt of I don't test my code often, but when I do it in production. We found a few bugs yesterday, and we were fixing them rapidly. But so far, it seems great, and I hope you guys are enjoying it as well.
Very much so. Thank you. So I have a few more slides, but I want to open it up to questions as well. But just to allow you to get going, you can go off, and if you want to give Windows Azure a try for just playing around with dev, we have a $200 free trial, and you can go out. We give you the credits. There is also a spending limit, so if you use that $200, you will not go over. Your credit card won't be charged. It's just able for you to go in, play around, and see what you want to do. So if you wanted to go and set up your own SocialCloud app, you're very welcome to do so. Enter in the contest. So we're still running the contest today. When the Expo Hall opens back up again, we're going to be firing, or the app's already fired back up, but we're going to go and look at that incoming queue and start approving messages and have you guys win some Mini Cooper RC cars. So all you need to do is include a photo with the hashtag ZenCon and Windows Azure, and we're good to go. And thank you very much for coming out. And if you have any questions, please feel free to ask them. If you want to try and ask them now, well, we still have around 10 minutes. That's awesome because then everyone can hear. But if there is anything that you don't want to talk about too openly, you can see Nick or I over at the Windows Azure booth in the Expo Hall later on today. Thanks so much. Who will be the first to ask a question? Not a single person has a question? Like, most of the times we'll get like, how much does it cost? No? There we go. There you go. The pricing, so we actually have this awesome pricing calculator. So if you go to windowsazure.com, you'll see a pricing section. And you can go, we have a pretty complex one, so you can see how many instances that you want, what size, if you want a Linux or Windows VM, or you want to take advantage of like Windows Azure websites, which you get 10 free sites, which is pretty awesome.
Does it like scale up? Say you have like this big long code where you're going to have like a million people hitting it. Can you scale it up and scale it back down? Or is it, would you like say, hey, when you get here, please? Can you repeat the question?
Sorry? Yeah, I'll repeat the question. So the question was, so I go and I provision these things, but can I scale it up and down, or am I kind of stuck with the number of instances that I selected originally? Yeah, that's the whole benefit of the cloud, is the ability to elastically and on demand go and scale out those resources. So yeah, you can definitely do that. We do have the ability to auto scale our services as well, so you can do like a CPU meter, and you can do like a min and max amount of instances, and we'll just keep an eye on the CPU performance and go and scale appropriately. Yeah.
Do you guys have, in Canada, we have rules around healthcare data. It has to stay in Canada and cannot leave AWS.
Yeah.
Patriot Act. So if we're in Canada, do we have a cloud operation anywhere in Canada, or does it go all around?
I'll repeat the question. So the gentleman here is a fellow Canadian. Nick and I are also Canadian. Yeah, so the question was around the Patriot Act and if there's services in Canada. Currently, there's no data centers in Canada right now, but if you want to come talk to us later, we have some information around the Patriot Act that you might want to take back and talk to some legal counsel with, just to see what things that you do actually have to be careful with, and yeah.
Can we just pop up the screen real quick? Yeah. So just this is what we're going to be turning on again in the next 15 minutes. And just FYI, this is the kind of the backhand queues, and as Eli was describing, this is what we just see come through, and it's as easy as approving a couple of them. And now they're here in our approved entries, and then we can pick a random winner whenever the competition will start. So let's just refresh, and there they are. So it's kind of nice and simple, very straightforward, and this is all running right now on the VMs.
Did my website come through?
So
do you want the URL?
Yes.
Yeah.
Yeah, it's SocialCloud.cloudapp.net. I'm just gonna zoom in. Oh, that's the app that was that Corey deployed.
So I just wanted to show off one thing, just to kind of hit on the point of the auto scaling there. If you want to go.
Can we just keep the presentation running?
So here's the website that I went and deployed earlier. And we do have a section here for configuration. So you can go and select the different version of PHP you want. So we have PHP 5.3 and 5.4 right now. Support for PHP 5.5 is coming relatively soon. Down here in your deployments, this is all the stuff that's coming from GitHub, so you can actually see your service hook here. So if you ever did want to go and type something in. And one last piece is, because we're using like an open source application and we have the ability to pull stuff in from GitHub, it's a good idea to have your configuration files and whatnot not referencing any production data. So you have the ability to go and enter app settings within this portal here, and they get exposed as environment variables to your machine. So you just do a very simple $getenv and pull in the actual app setting to hydrate your configurations, which is pretty neat. That auto-scaling piece that I was talking about, you just go into the Scale tab. Auto-scaling is currently in preview, but you can go in here. You can vertically scale, so you can go and say, I currently have a small instance, but I can go to a large instance if I want to. And then here's our scale metrics, so we can say, scale my CPU. There we go. And then we have a simple instance count. So because it's in preview right now, you probably have a limited number of instances you can scale to, but I can go up to 10. And you can see here my target CPU is, when it hits into that 60%, start thinking about scaling. When it gets closer to 80, definitely start scaling up. And it will only go up to the max number of instances that you set here. So if I only say 5, we'll only take you up to those 5 instances. And it's something that you can set here in the portal, you can set with those command line tools, or you can, the auto scale you can't, but if you did want to go manually scale, you could go and do that from the command line tools themselves.
And if you want more info and demos, just stop by our booth. I'm happy to walk you through it.
No more questions? Who's going to go try Azure?
Yeah.
Sweet. About 4 people. That's not bad. Cool. All right. Well, we still have about 3 minutes left, so we'll stick around here in front of the stage. But if you want to carry on to your next presentation, we completely understand. Thanks so much for joining us today, and enjoy the rest of ZenCon.